everyone. Today we're going to be working with ratios and comparisons. So a ratio is a comparison of two quantities by division, but you can also kind of think of it as an equation stating that two rates are equal. So an example is 2 to 7, which is also equal to 4 to 14. That sounds really confusing, so let's break that down a little bit. Before we begin with that, though, you actually have probably heard ratios in different situations. The biggest one that I can think of is particularly with sports. There are some people that calculate the odds, and they'll say like team one to team two, it's a 2 to 1 on or ratio. So that's kind of a situation where you'll see this in real life. But let's kind of break that down for you. So here we go. I have an example with some stars and some circles. So in total, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have a total of 10 shapes. I can count that there are 6 stars and 4 circles. So that was just literally counting the objects that we have. We're going to take what we have with that, and then we're going to put it as a ratio. So an example for that is for every certain amount of circles, there are blank amount of stars. So before we said that there were 4 circles and 6 stars. So if I took my 4 and my 6 and I simplified it by dividing by the greatest common factor, I would get 2 circles and 3 stars. So that's what I'm going to write down. For every 2 circles, there are 3 stars. And that's a ratio. So ratios can be expressed in a couple of different ways, 3 in particular. One is in written form. So circles to stars, I can say 2 to 3. I can also say there are 2 circles for each 3 stars. And I also can say there are 2 circles for every 3 stars. So again, all we're doing is we're comparing the amounts. We're comparing the amount of circles and comparing the amount of stars. And there's a variety of ways to say it. Written form is just one of them. Another way to write it down is what's called odds notation. And odds notation takes the amount of circles. You write that down first. And then you use 2 dots. Those 2 dots are like that indicator saying, hey, this is a ratio. And then you write the amount of stars. So this is another way to say the 2 to 3. So for every 2 circles, there are 3 stars. And finally, you can write this as a fractional notation. So what we will just write as that is make it into what looks like a fraction. So 2 divided by 3. Remember, this fraction line doesn't always mean a fraction. It can mean division as well. And that's what it means in this case. So fractions and ratios are not the same thing. Instead, fractions represent one number while ratios compare two quantities. It can be really confusing. You might be asking, well, how do we know when it's a fraction and how do we know if it's a ratio? And I promise you we will get to that in just a moment. So ratios can compare quantities in 3 different ways. So there is not just only one set of quantities that we can compare. Instead, we can compare in 3 different ways. One is part to part. And an example of that is circles to stars. So we have one set of shapes being compared to another set of shapes. And we can compare that by either writing it as 2 to 3. We can use the 2 dots again. Or we can make it into a fraction, which is not actually a fraction, it just looks like a fraction. The next type of a way that you can compare quantities is by part to whole. So in this example, I have stars to shapes. So we have one shape compared to all the shapes together. So that's what the whole part means. So I'm going to write the amount that I have first for my part. So that is the amount of stars. And the amount of stars that I have is 6 altogether. And that is 6 to 10. You can, of course, simplify it. I'm just going to write it in this way for the purpose of showing you where these numbers come from. I can also use my 2 dots again or make it into a fraction. And the third way is by taking the whole and comparing it to the part. So in this example, I have shapes to circles. In total, there were 10 shapes. And I'm comparing that to the 4 circles that I had. Again, of course, simplify it, but I am writing it in this form so that you can see where these numbers are coming from. So again, I can use my 2 dots, or I can put it in a fraction, which is not actually that fraction. When you're writing ratios, you don't have to write it in the 3 different methods every single time. One might be better than another in a certain situation. So I just wrote down all of them so that you can see. This little star right here is the answer to probably a lot of your questions. So it says, pay attention to your wording. Your ratio must stay in order to make sense. So the way to tell if a fraction is a fraction or if it's a ratio is if there are words with it. So if it tells you what they're comparing, for example, stars to shapes, then we know that this is not a fraction and instead of ratio. Again, it's super important to make sure that your words are in the right order because we want to know what these numbers mean. So if I'm just given 2 to 3 without any background knowledge, I don't know what I'm comparing. But if I write circles to stars, I can see that I have 2 circles to 3 stars. If I do not have that, I don't know what 2 and 3 mean. So it needs to make sense. You can't switch up the order. It has to be exact. Okay, so we can visually see ratios in a couple of different ways as well. So the first way is with models. So you can physically model out how many circles and how many stars there are with boxes, circles, any shape that you would like, just to visually see what the comparison is. Another way that you can use is a ratio table where you write out the amount of circles and stars and compare them by just looking at the different numbers. The next type of way is tape diagrams, and that actually is one of our vocabulary words. Tape diagrams can come in a variety of forms. Here are just 2 examples of them. That tape diagram is called tape diagram because it's a diagram that looks like a piece of tape. So it's thin and narrow and shows a ratio. So in the first example, I have 2 squares that represent the amount of circles that I had. And I'm comparing that to the amount of circles, or sorry, the amount of squares that I have. So I have 1 extra square to represent that extra star that I have. Or you can also have it in one long line. So I have my 2 squares that represent my 2 circles, and then my 3 squares that represent the 3 stars, because we have been using 2 circles to every 3 stars, and that can be shown in this method as well. The last 2 forms that we can see ratios in are on a coordinate plane. So another word for coordinate plane is a graph. By using titles and labels, we can see the ratio of 2 to 3 by graphing 2 on our x-axis, 3 on our y-axis, and meeting them together at this point. And the last is what's called a double number line. This line takes the amount of circles, goes down the line right here. So our amount of circles was 2. And then the amount of stars would be down below for where our 3 is. So some models may be better for different scenarios. It's really up to what you're trying to solve. But to fully understand the ratios, you need to know all the models, or at least be familiar with them. Now you might have noticed on the models I had numbers other than 2 and 3, which is what we were really working with. But this is where our past knowledge of equivalent fractions come in, because the methods that we use to find equivalent fractions can be used to find equivalent ratios as well. So if we wanted to compare a larger amount of circles and stars, we can use equivalent methods in order to find it. And that method is going to be to multiply or divide both amounts by the same number. The exact same thing we did with fractions. So if I had a ratio of 2 to 3, I can multiply both numbers in order to get a new ratio of 4 to 6. So let's say I had in the hundreds the amount of circles and squares. I can multiply by 100 and I can see the relationship. So that is your notes, or that concludes your notes for ratios. If you have any questions, please let me know.